Yes, good morning, students. So, myself Vishnu Prasad here. So, we'll continue the ATD Class 2. So, yesterday I was explaining about the uh, some performance parameters I have explained you, like that, like brake power and indicated power. Okay. And given some importance of uh, how factors of detonation and knocking. Okay. So we'll continue some more performance parameters that we have. So before going for that, I was telling you yesterday how to determine the torque. So in order to find the brake power, we should know how to calculate the torque. So we have different types of dynamometers to determine the torque. Okay. So I told you yesterday there are three types of dynamometers, like a brake drum dynamometer, eddy current dynamometer, and hydraulic dynamometer. So in order to know how the torque is developed, we have three different types of dynamometers. So in that I will explain you about the brake drum dynamometer today. Okay. So actually for your syllabus we have only one type of dynamometer, that is brake drum dynamometer. Okay. So in order to determine the torque using the brake drum, so the engine has been you are to start the engine. So at different loads you are going to determine the torque. So first you start the engine at without load, and you go on adding the load. So usually the load that what we are going to apply will be in terms of kgs. So but we required in terms of newtons to convert into kilowatts. So if you multiply it by 9.81, you will get in newtons. Okay. So it is necessary to measure the torque by coupling the measuring device at an engine shaft, like dynamometers we have. So we have brake drum dynamometers, hydraulic dynamometers, and eddy current dynamometers. So here a diagram you can see, it is one type of dynamometer to measure the torque. It is a brake drum dynamometer. So I'm going to zoom it and show you how the brake drum dynamometer looks. So you can see here we have a brake drum at the top. Okay, and it is surrounded by the rope. One end of the rope we are going to apply the load W. The other end it is connected to a spring balance, which is S. Okay, and capital D is the diameter of the brake drum, and small d is the diameter of the rope. So how to calculate the torque? Torque is nothing but force into perpendicular distance. So what is the force that we are applying here is nothing but the load. The load itself is calculated into force in terms of newtons. The force into perpendicular distance gives the torque. The force what we are applying is nothing but the load. In the bracket it is written as W minus S, that is the force. So W is the load, and S is the spring balance reading, which is tied on the other side of the brake drum. Okay, so W minus S gives the net load that is applied on the brake drum. Suppose if the W is given in terms of kgs, you have to convert into newtons by multiplying by 9.81. So I am going to repeat to students once again. So in some cases they may give directly in terms of newtons, and sometimes they may give in terms of kgs. So if they are given in kgs, you please multiply by 9.81 to convert into newtons. So the force that is applied is W minus S, and the perpendicular distance is nothing but rope dia plus brake drum dia divided by 2. So rope dia is nothing but small d, and brake dia is given by capital D, divided by 2. Why we are dividing by 2 means it is exactly up to the center point of the crankshaft, that is the force into perpendicular distance. So force is measured in terms of newtons, and perpendicular distance is measured in terms of meters. So Newton meters is nothing but the torque, but when you convert into kilonewtons, it will become kilonewton meters or kilojoules, we can say. Okay, So here you can see here it has been clearly mentioned that d is the diameter of the flywheel in meters, small d is diameter of rope in meters, w is the load or weight in kgs, it will be there. You have to multiply by 9.81 to convert into newtons, or directly they may give you newtons. And S is the spring balance. See, always you have to be careful while solving the numericals. All the units should be in same, either in newtons or in kilonewtons. Okay, don't put one in newtons and other in kilonewtons. And also here, when you come to the capital D and small d, that is a brake drum and rope dia. Okay, so everything should be in terms of meters. Don't put one in mm, another in centimeters and another in meters, like that. So you have to be careful while substituting. If you make a small mistake here, the entire problem will be wrong. So be careful that unit should be same. So this is how we are going to calculate the torque. So torque is nothing but the load that is applied on the how to determine the torque means with the help of the load that is applied on the brake drum. Okay, so torque is given by W minus S into capital D plus small d by 2. It will be in terms of kilonewton meters or kilojoules. Okay, so once after calculating the torque, now we can calculate the brake power. Okay, so yesterday I have given that formula how to calculate the brake power. Brake power is nothing but 2 pi nt by 60 into 1000. You can see here brake power is nothing but 2 pi nt by 60. That gives in terms of kilowatts. Suppose if you have put the torque in terms of newtons, in the denominator you have to divide by 1000, so that you will get in kilowatts. If the torque is in kilonewtons, then no need to divide by 1000 once again. Okay, so these are the common mistakes most of the students will be making. So observe clearly what the data is given, then you substitute here. Okay, so after getting the torque, after calculating the brake power, now we are going to calculate the mechanical efficiency. Mechanical efficiency is the ratio of output power of an engine to that of input power. So here the output power is nothing but the power that is available at the crankshaft, and the input power is nothing but the power that is available that is developed inside the cylinder by burning of the fuel. Okay, so that is nothing but the indicated power. I have explained in the last class, that is Planck. How to calculate the indicated power? It is nothing but Planck. Planck in the sense PLANK divided by 60, where P is the mean effective pressure, I told you, L is the stroke, A is the area of the piston, N is the number of cycles, K is number of cylinders, divided by 60. So after getting input power and output power, now the mechanical efficiency is calculated, that is brake power by indicated power into 100 to convert into efficiency. So that is about one more performance parameter. Now the next performance parameter is the thermal efficiency. So what is thermal efficiency means? It is the nothing but the ratio of the output power from the engine to the heat input. So what is the heat input we are going to supply here is nothing but by burning the fuel. Okay, so MF, it is nothing but MF into CV. So what is that MF and what is that CV means? MF means M suffix F. MF is nothing but the mass of the fuel that you are going to supply, and CV is the calorific value of the fuel. So again the calorific value varies from different types of fuel. Okay, for petrol it is different value, for diesel it is different value, and for kerosene it is different, and also for the gas it is different. So thermal efficiency is nothing but it is the ratio of output power from the engine to the heat input. Heat in output is nothing but the brake power that is available at the crankshaft, and the heat input is nothing but the amount of mass of the fuel supplied multiplied by its calorific value. Okay, so heat input to the engine by burning the fuel for a known interval of time. So brake thermal efficiency is nothing but BP divided by MF into CV. So we know that BP is measured in terms of kilowatts, or it can be watts, can be written as joules per second. So the unit you can see here, it is kilojoules per second. Okay, and MF, the mass of the fuel that is burned, means how much fuel you have supplied in terms of certain time. So it is kg per second. Okay, and calorific value is given by kilojoules per kg. So kilojoules, kg, s, all the units gets cancelled. So automatically brake thermal efficiency, since this is an efficiency, we won't get any units here. Okay, more this type of questions they will be asking you in the lab, students. In the next semester, what you are going to do, they'll ask you what is the unit of thermal efficiency. Don't say whatever the unit you want. So always you think, keep in one mind that efficiency will not be having any units, because all the units will be cancelled. So brake thermal efficiency is nothing but BP divided by MF into CV. So brake thermal efficiency is also equal to a just thermal efficiency. In the exam, if they ask you to calculate thermal efficiency or brake thermal efficiency, for both the formula is same. It is BP divided by MF into CV. Similarly, we have indicated thermal efficiency. So indicated thermal efficiency is nothing but it is the thermal efficiency based on the indicated power. So instead of putting the brake power in the numerator, if we put indicated power, then you will get the indicated thermal efficiency. So indicated thermal efficiency is nothing but IP divided by MF into CV into 100 to convert into percentage. Excuse me. So next we have volumetric efficiency. So what is volumetric efficiency means? It is nothing but the actual volume to the swept volume. So how to calculate the actual volume and how to calculate the swept volume is important, student, here. So the same things you will be doing in the lab, I told you, man, again and again I am explaining you. So you have to be familiar with these formulas. Okay, so volumetric efficiency is nothing but actual volume by swept volume. It is nothing but VA divided by VS. So VA is nothing but the actual volume, VS is nothing but the swept volume. Swept volume means the piston will be moving from one dead center to the another dead center, that is from top dead center to the bottom dead center. So that is called as the total swept volume inside the cylinder. So swept volume is given by pi by 4 d square L into N. Okay, so what is that D? D is nothing but the dia of the piston and L is the stroke of the piston. So Vs is given by pi by 4 d square L into N. So you be careful while substituting N here. So it is not the capital N, it is a small n. Small n indicates number of cycles and capital N indicates RPM. So again small n will be different for the different engines, if it is a 2-stroke or a 4-stroke. For 2-stroke engine, small n is equal to capital N. Whereas for 4-stroke engines, small n is equal to capital N by 2. This I have explained you already while explaining in the indicated power, I think. Okay, so once again you go through that previous class. Okay, so after calculating the swept volume, it is nothing but pi by 4 d square L into N. It is given in meter cube per minute. If you divide by 60, it will become meter cube per second. Okay, so now you have to calculate what is the actual volume. So what is that actual volume means? The amount of air that is taken inside the cylinder. Okay, amount of air that is taken inside the cylinder is nothing but the actual volume. It is given by VA. So VA is equal to CD into A naught under root 2GHA. Okay, so what is CD means? It is the coefficient of discharge. What is that coefficient of discharge means? It is the, we will be having a small orifice meter through which the air enters into the cylinder after filtering. Okay, so that orifice, it is nothing but orifice meter it is called, where we are going to calculate the amount of air that is entering. It is the coefficient of discharge. So it will be varying from 0.6 to 0.65. Okay, so how to calculate VA means VA equal to CD into A naught under root 2GHA, where CD is nothing but coefficient of discharge of an orifice meter, and A naught is nothing but area of the orifice meter. Okay, so they will give the diameter of the orifice. You are supposed to calculate the area of the orifice, that is A naught equal to pi by 4 d naught square. Okay, small d suffix naught. Suffix naught indicates orifice diameter. So by knowing the orifice diameter, you are supposed to calculate the area of the orifice. Okay, so CD is the coefficient of discharge, A naught is the area of the orifice meter, and under root 2GHA. So 2 is constant, G is acceleration due to gravity, and HA is the head of the air. So now how to calculate the head of the air? Okay, so head of the air is nothing but we have to calculate first what is the how to calculate the head of the air means head of the air is nothing but the pressure of air that is entering into the engine cylinder. So by balancing with the using of manometers, okay, that using the water manometer, in some cases it will be having water manometers, in some cases we will be having mercury manometers. So depending upon that, you are going to calculate the head of the air by balancing. So suppose if we have a water manometer, we will be having HW into rho W equal to HA into rho A. So HW is head of the water, rho W is density of the water, that is equal to HA, head of the air, into rho A, density of the air. So we have to calculate, we have to note down HW, rho W, density of water is 1000, rho A, density of the air we are supposed to calculate, and with the help of this you are going to calculate the head of the air. That head of the air, H suffix A, is substituted under root, and we are going to calculate the volume of the air. Okay, so after knowing this volume of the air, we are going to calculate. So also we know that PA VA equal to MRTA. So the another way to calculate the volume of the air is this one. So if they have given orifice diameter and coefficient of discharge, head of the water, okay, then we have to apply the above formula, VA equal to CD into A naught under root 2GHA. Or if they have given the atmospheric pressure, mass of the air, and temperature, we have to calculate VA equal to MRTA by PA. These are the two methods to calculate the actual volume of the air. So after calculating the volume of the air, now we can calculate the volumetric efficiency. It is nothing but VA by VS, actual volume by swept volume. Okay, so this is how we are going to calculate the volumetric efficiency. Okay, so the another term we have here in performance parameters is nothing but specific fuel consumption. So what is that specific fuel consumption, SFC? It is nothing but the amount of fuel consumed by the IC engine to produce the desired amount of energy. Okay, so it will be in terms of brake power and also in terms of indicated power. So specific fuel consumption based on brake power is nothing but it is called BSFC. It is nothing but the brake specific fuel consumption. So it is nothing but mass of the fuel divided by brake power. So you can see here, you can look here, BSFC is nothing but MF by BP. So MF usually what you are going to get, it will be in hour basis. So it is kg per hour, and BP will be in kilowatts. So the unit for brake specific fuel consumption, it will be kg per kilowatt hour. Always the specific fuel consumption will be in terms of kg per kilowatt hour. Okay, so that is about the specific fuel consumption with respect to the brake power. Similarly, we can calculate the specific fuel consumption based on the indicated power, that is ISFC. It is given by ISFC is equal to MF by BIP. So again it is in kg per kilowatt hour. Okay, so this is how you are going to calculate the brake specific fuel consumption and indicated specific fuel consumption. So these are the some of the performance parameters, students. So where we are going to solve the numericals based on these performance parameters. So I'll show you once again one by one. So in the last class we have calculated indicated power. In today's class I have shown you how to calculate the brake power and what are the instruments to calculate the brake power. We have different types of dynamometers. In that I have explained you one dynamometer, that is the rope brake drum dynamometer, to determine the torque. So after calculating the torque, substitute here in brake power formula and find out the brake power. So after finding the indicated power and brake power, we are going to calculate the mechanical efficiency and brake thermal efficiency. And by knowing the indicated power, we are going to calculate the indicated thermal efficiency. And next we are going to calculate the volumetric efficiency. It is nothing but actual volume by swept volume. So swept volume is given by pi by 4 d square L into N, and actual volume is given by C suffix D A suffix naught under root 2ZHA, where C suffix D is coefficient of discharge, A suffix naught is area of the orifice meter, dia of the orifice meter will be given. So you are supposed to calculate the area of the orifice meter. And next, after knowing this VA and VS, we are going to calculate the volumetric efficiency. Similarly, we are going to calculate specific fuel consumption. This is the another performance parameters where we are going to calculate. So based on brake power, we have BSFC. It is nothing but mass of the fuel consumed per unit kilowatt hour. It is kg per kilowatt hour, MF by BP. Similarly, based on indicated power, we have ISFC. It is nothing but MF by IP. So once again it is in kg per kilowatt hour. So in the next class I will explain you how to calculate the heat balance sheet. What do you mean by heat balance sheet, and what are the things we are going to consider in heat balance sheet, how the heat is supplied and how the heat is carried away by various process. So the same thing you will be doing experimentally in the next semester. So theoretically you are going to study in this semester. So that will be the last top performance parameters, which I am going to explain you in the next class. So after that we will solve some more some problems based on this. Then we will come back to the second part of this chapter, that is Morse test, how to find the indicated power. We have different methods to determine the indicated power. So one is Williams line method and another is the Morse test method. So time for the today's class, these are some of the performance parameters which I have shown you. In the next class I will explain about the heat balance sheet. Okay students, so you please you can go through this and you can download this, you can save it, whatever you want you do it, or you can take some material somewhere in the Xerox centers also. Okay then.